Hi future doctors, welcome to the next class. I think I gave one problem as homework for you people. Four masses placed at four corners of a square of each side small a. I hope all of you people did or tried who are following us. Now this is the axis of rotation I gave. So all these mass particles are rotating like this. So you have to take this distance. This distance we came to know if it is a root 2a. If it is L, root 2L. Now we want this distance. So this is going to be perpendicular distance. Correct? Whenever you are extending like this is the perpendicular distance. This is also perpendicular distance. So whenever these are perpendicular distances, so this is angle is going to be 90. These two angles are equal, therefore it should be 45, 45 because total angle should be 180 degrees. So for this 45, this side is L is going to be which side means opposite side. So if it is A, this one will be A cos 45. This one will be A sin 45. Correct? Because opposite side always 45. Otherwise, sin 45 is equal to opposite side by hypotenuse. Hypotenuse is going to be this. So, however, you are going to solve, you are going to get this distance as A by root 2. So, L is equal to A by root 2. So, moment of inertia, if you are taking A, B, C, D, I is equal to IB is 0. IA plus IC plus ID. What is IA? M. What is the perpendicular distance? L square, not A square. A is at a distance, perpendicular distance L. So ML square plus IC. That is also ML square plus ID. M root 2A whole square. So L is nothing but A by root 2. So A by root 2 whole square plus M A by root 2 whole square plus M into 2A square. So MA square by 2. MA square by 2 plus MA square by 2 plus 2MA square. This is going to be 2MA square by 2 plus 2MA square. So this 2 will be cancelled. That is going to be 3MA square. Correct? Just you can cross check once calculation. So this is going to be how we are going to solve the problem by taking perpendicular distances. Now we discussed already parallel axis theorem, perpendicular axis theorem. So for that we will see moment of inertia of the ring and disc in this class. So ring means if you are taking ring of radius r, so if it is rotating about its own axis, if it is rotating about its own axis, what is the moment of inertia? If you are taking disc means like rupee coin. Now if it is rotating about its own axis, what is its moment of inertia? So in this, for ring, I is equal to simply mr square. So axis is passing through its center perpendicular to its plane. Passing through center perpendicular to plane about its own axis. If this is the ring means this is the axis of rotation. It is rotating like this. This is the axis passing through its center. For its plane, this axis is perpendicular. Next, another one. If ring is going to be rotated like this. So if it is going to be rotating like this is the axis. This axis name is tangent perpendicular to its plane. If this is the ring, this is one axis which is passing through its center. Another one is this one. Now this axis name is tangent perpendicular to plane. This one. This is tangent perpendicular to the plane. How these two axes means? These two axes will be parallel. Therefore, which theorem we have to apply? Parallel axis theorem. I is equal to I naught plus mr square. What is I naught? Already we got about this axis. M r square plus mr square. So 2 m r square. Next, about diameter. If ring is rotating like this, about the diameter. So about diameter means it will be rotating like this. If this is the ring means it will be rotating like this. This is the diameter. So another name, passing through its center parallel to its plane, like that also I can take. So for this case, I is equal to about the diameter. How you can get means this is mr square. This one. This is 2mr square. Now this one is, if it is mr square means this one is going to be half of the mr square by 2. Just to remember one logic we are giving. If it is mr square means this is half of mr square by 2. Next, this one. This tangent is parallel to plane. Previous one tangent perpendicular to plane. This one. Now tangent parallel to plane. How it will be coming means, same ring I am taking. This is the axis of rotation. Already this one we came to know, I naught. How these two axes? Parallel. Therefore, I is equal to I naught plus mr square. What is I naught? Mr square by 2 plus mr square. So 3 by 2 mr square. So finally, you should remember this 3 by 2 mr square. This is mr square by 2. This is 2 mr square. So for this center perpendicular to its plane, diameter half. Okay, is it visible? Next, whenever it is going for disc, so it is also like this, but here matter will be there like rupee coin. So same axis perpendicular to its plane. This is about diameter. This is tangent parallel to or perpendicular. Tangent perpendicular to its plane. Tangent parallel to its plane. This one another name is about diameter. So for the disc, this value same axis, center perpendicular to its plane is m r square by 2. So for this one, so for the disc, about tangent perpendicular to its plane, this one. Tangent perpendicular to its plane, I is equal to, this is I naught. I naught plus mr square. What is I naught? Mr square by 2. Mr square by 2 plus mr square. 3 by 2 m r square. This is tangent perpendicular to its plane. Now about diameter. So about diameter means if this is the disc, what is the axis of rotation means about diameter. About diameter, how you got? Mr square became mr square by 2. Now mr square by 2 will become mr square by 4, half of that mr square. Same like ring one. So in the case of ring, what we said? So if it is mr square, this one is going to be mr square by 2. For disc, if it is mr square by 2, this one is mr square by 4. Next, about tangent in its plane. Last one, this axis. About tangent in its plane means same formula you will get. So I is equal to I naught plus mr square. What is I naught? So mr square by 4 plus mr square. So 5 by 4 m r square. So that is going to be moment of inertia of the disc about tangent. So logically you have to remember. So to remember, this is the logic you can remember. Ring you can take. So axis you can change. Names you have to recall. Passing through its center perpendicular to plane mr square. About diameter half of this mr square by 2. If it is disc, passing through its center perpendicular to plane mr square by 2. So about diameter half of that mr square by 4. Next, this axis is tangent perpendicular to plane. Ring means tangent perpendicular to plane. This is mr square. This one if you want means 2 mr square. Correct? Now diameter is mr square by 2 for ring. Now this one is mr square by 2 plus mr square. 3 by 2 mr square. Next, for disc, it is mr square by 4. Now for this, mr square by 4 plus mr square, 5 by 4 mr square. So without these formulas, we cannot solve the problems. So ring and disk we discussed, like this: hollow sphere, solid sphere, rectangular lamina. Okay, for rod which is having length. So all those we will discuss in our next class. Okay, now try to remember all these formulas by recalling. Definitely you will remember.